Geometry 4-1. For most of this lesson, we're just going to copy down what I've already written instead of me writing all of this down. So I'm going to, we're just going to talk through each of these and you can write this down. So 4-1, classifying triangles. Just make sure you pause if you need to catch up. So here's some review. So we've just drawn this triangle ABC. The sides of triangle ABC, notice how I just have a little triangle ABC, are AB, so that's segment AB. Notice there's a line on top of here without arrows, so it's just a segment AB, segment BC, and segment CA. So those are the sides of the triangle. The vertices are points A, B, and C. That's where the segments meet, so those are the vertices. The angles are angle BAC, so that's angle A right there, BAC, or angle A. Angle B here is also ABC or CBA, that's fine, still that angle. And then the last one, angle C, is also known as BCA or ACB. Notice how the point in the middle is also the name of the angle when it's just one point. Classifications of triangles by angles. So this should be something that you learned years ago, but we're gonna review it and hopefully fill in any gaps that you might have. And so we have an acute triangle. That means that all of the angles are less than 90 degrees. So 3 acute angles, less than 90 degrees. Equiangular triangle means that all 3 angles are congruent. All 3 angles are the same. They're all acute angles, so equiangular triangle is also an acute triangle, but it's a special kind. And each angle is the same as all the other ones, which means it's 180 divided by 3, which is 60 degrees. All right, each of those angles is 60 degrees. Obtuse, you've got one obtuse angle. It's not possible for a triangle to have 2 obtuse angles, but it can have 1 and then 2 acute angles. If it has 1 obtuse angle, which is greater than 90 degrees, that's what makes it obtuse, then you have an obtuse triangle. A right triangle will have 1 90-degree angle. You can't have 2 90-degree angles, or otherwise you end up with a square or something like that. One right angle makes a triangle a right triangle. And that little box there in the corner tells you that it's 90 degrees. So here are some examples. Let's talk about each of these and draw them on your paper. So this one, triangle here, 70 degrees, and 40 degrees. So all of these angles are less than 90 degrees. So this is an acute triangle. This triangle, 90, 60, 30, this has a 90-degree angle in it, so it is a right triangle. Now this last triangle here, 97, 49, 34, this triangle has one angle that is greater than 90 degrees, therefore it is an obtuse triangle. All right, let's look at another example. So we're going to draw this PQR, triangle PQR, with another line right here in the middle making S. So we have really 3 different triangles. We've got triangle PQR, we've got triangle PQS, and we've got triangle PSR or PRS, or however you want to say it. So let's talk about which triangles are what classification. So PQS here, I've got 45 degrees, and this angle here is 90, so that means this angle has to be 90 as well. So PQS has a 90-degree angle, so it is a right triangle. QSR also has a 90-degree angle, so it is a right triangle as well. PQR, this whole triangle, the big one, this has an acute angle here, an acute angle here, 45 and 31. Now this angle here, angle PQR, this whole angle, if we add 45 and 59 degrees, those two angle measures there, then we end up with 104. So 104 is greater than 90 degrees. So PQR, triangle PQR, is an obtuse triangle because this angle is 104 degrees. Okay, so now we've talked about classifying triangles by angles. Now let's classify triangles by sides. Okay. So we've got three different kinds of classifications for triangles by their sides. So an equilateral triangle has three congruent sides. All three sides are congruent. An equilateral triangle is also an equiangular triangle. Equilateral is also equiangular. Every time, all of these angles are going to be congruent as well, so that's 60 degrees for each of these angles. Equilateral and equiangular are the same triangles, but we're just talking about them. Equilateral, we're talking in terms of sides. Equiangular, we're talking in terms of angles. Still same triangle. Isosceles has at least two congruent sides, so I'd put two marks here to say this side is congruent to this side. So an isosceles triangle has two congruent sides, at least. Equilateral triangles are a type of an isosceles triangle because two sides are congruent. It just so happens that the third side is also congruent. All right, isosceles, two congruent sides. It also, an isosceles triangle, these two angles down here are going to be congruent as well. We'll talk about that later. Scalene, no congruent sides. All the sides are different length, so that is called a scalene triangle. So here is an example for us to do. So if you draw a triangle, and then you draw a little rectangle coming off, and then a little, this is called the head of the guitar up here, or lute, or whatever it is, and or headstock. And then if you just draw a little back end of this, and then you do a little circle for the sound hole, and then you have a little guitar here, or lute, or whatever it is. So this side here is 16 inches, this side here is 16 inches, and the base is 18.5 inches. So this is a real-life example of what type of triangle. 16 inches, 16 inches, 18.5 inches. This triangle here is isosceles because it has two congruent sides. So this would be an isosceles triangle. Now this looks like a weird shape for a guitar, but I actually have seen guitars this shape. A friend of mine actually made one, built one this shape to play slide guitar on. It was pretty cool. But anyway, there it is. Now here is another example here. So we're going to draw this KJL, draw KJL, and then draw a line segment from K down here to M. And so you've got 1, 2, 3 triangles here. KL is 1.3, KJ is 0.75, JM is 0.75, and KM is congruent to ML. So we're going to talk about what kind of triangles we've got going on here. So let's talk about each triangle. We've got 3 different triangles, so let's talk about each one. So KML, let's talk about that one first, KML. Notice how KML has KM and ML, those are congruent sides. So that means KML is isosceles because it's got 2 congruent sides. Now, let's look at KJM. Let's look at this one in here. KJM has 0.75 here and 0.75 here. So that means KJ and JM are congruent, so it's isosceles. But let's look a little bit deeper here and see what this side might be. We might have an equilateral triangle happening here. So if JM is 0.75 and then JL is 1.5, what is ML? So if JM is 0.75, JL is 1.5, what is ML? So we just subtract 1.5 minus 0.75, and we end up with 0.75. So that means that ML is 0.75. And if KM and ML are congruent, then KM is 0.75 as well. So that means all of these sides are 0.75, so this is an equilateral triangle. Triangle KJM is equilateral. Now let's see KJL, triangle KJL. What is that one? One side is 0.75, one side is 1.3, one side is 1.5. So none of those sides are congruent. Therefore, we have a scalene triangle. All right, we're going to do 2 more examples. So we're going to have a triangle. Looks like this. These 2 sides are congruent. This is triangle ABC. AB is 9x minus 1. BC is 5x minus 0.5, and AC is 4x plus 1. All right, I want you to find the side measures. So we want AB, and we want BC, and we want AC. So we've got 3 sides to find their measures. Okay, so the first thing we need to do is we need to find out what x is. And in order to do that, we need to somehow find a relationship between some of these sides and solve for x. Since AC and BC are congruent, then I can take this measure and set it equal to this measure because they're congruent. So I'm going to say 4x plus 1 equals 5x minus 0.5 or 0.5. So now I'm just going to solve for x. I'm going to subtract 4x from each side, and I'm going to add 0.5 to each side. Those go away, those go away. I've got 1.5 equals x. 5x minus 4x is 1x. So x is 1.5. All right, I'm not done yet. They didn't ask me what x was. They asked me what the sides are. So side measures. So I'm just going to plug x into each of these sides. So let's do AB first. 9 times 1.5 minus 1. 1.5 times 9 is 13.5 minus 1 equals 12.5. So AB is 12.5. Let's do BC now. 5 times 1.5 minus 0.5. All right, 1.5 of 5 is 7.5, right? 7.5 minus 0.5 equals 7. So BC is 7. Now, if BC is 7, do I need to plug in my x value for x to find out what AC is? No, I don't, because I know BC and AC are congruent. There you go. Now, if you wanted to check your work, you could plug 1.5 in for x here and see what you get. You are going to get 7, because 1.5 of 4 is 6. 6 plus 1 is 7. So, so we did do that right. One more example. Triangle FGH is equilateral. Equilateral. Okay. Find the side measures. So remember, equilateral means all the sides are congruent. Let's draw FGH. Remember, it's equilateral, so all the sides are congruent. 2y plus 5 is FG, GH is 3y minus 3, and FH is 5y minus 19. Okay, so now I'm just going to choose two of these to set equal to each other because these are all congruent, so I just need to solve for y. But I'm looking for the side measure, so I need to remember that, that I'm not just looking for y, I'm looking for the whole side, how much each side measures. So I'm going to choose GH and FG. Doesn't matter which ones you can choose whichever you want. I am going to say 3y minus 3 equals 2y plus 5. And so I'm just taking GH and set it equal to FG. I'm going to subtract 2y from each side, and I'm going to add 3 to each side. So those 2 y's go away, and the 3's go away here. So 3y minus 2y is y, and 5 plus 3 is 8. So y is 8, which is cool, but that's not my answer. What I need to do is plug that 8 back into any of these, and I will get my side measure. I'm going to plug it into the easiest one. 2 times 8 plus 5 equals, 2 times 8 is 16, 16 plus 5 is 21. All of my side measures are 21 because they are all congruent. I could plug 8 into every single one of these, I'd still get 21. 8 times 3 is 24, minus 3 is 21. 8 times 5 is 40, 40 minus 19 is 21. So I've just checked that out. All of the sides are 21 inches or whatever the units are. And that is the end of 4-1. Good luck on the homework.